Okay, section 6.2, polynomial and linear factors. So the first part of this particular lesson is going to help you sort of make some connections, I'm hoping. So the factored form of a polynomial, we did factoring back in chapter 5 where we took all kinds of polynomials and we factored them down into the two things that we would have multiplied together to give us that particular polynomial. So just as you can rewrite a whole number as a product of its prime factors, you can write a polynomial as a product of its linear factors. So we're going to use these two examples. One of just a plain old constant that we're so familiar with. So 6 can be prime factored down to 2 times 3. Right? 2 times 3 are the factors, the things that I multiplied together to give me the product of 6. Okay? And so I think we're all really good at understanding that. 2 times 3 gives me 6, or 3 times 2 also gives me 6. And then I can take 6 and divide it by one of the factors 2 and get the other factor 3, or I could have taken the 6, divided it by the factor 3 to get the factor of 2. This was called a family of facts. Okay? And we did that a lot when you were really young in elementary school working with different factors. First you learned multiplication, and then you learned that those factors that you multiplied together gave you this product. You can do that in the reverse order. And so that's what we've been doing with our polynomials. We've been taking those things that we multiplied together. We learned how to multiply and FOIL them all out and get all these wonderful polynomials. Now we're learning how to take them apart and tell what factors we used to get them. So the example we have x squared plus 4x minus 12. If I factored it down, remember factors of 12 are 1 and 12, 2 and 6, 3 and 4. And so I would do positive 6 minus 2. Right? These are my factors. Those are the two things that I multiplied together that gave me this product. And so I can treat this just like I can treat my family of facts for the facts of 6. I can say x plus 6 times x minus 2 gave me x squared plus 4x minus 12. And I know that when we first learned how to do this and we broke them down and we said the factors were x minus 2, x plus 6, some of you said, well, is it okay to have x plus 6 times x minus 2? And the answer was yes, because multiplication is commutative. It's going to still result in x squared plus 4x minus 12, so that's okay. And we could also do division. That's essentially what we're doing when we are breaking them down into their factors. We're dividing out that polynomial by an x minus 2 to get the x plus 6. Okay, so essentially if I take out this equal sign and maybe move my parentheses a little bit, right, I can say that if I did x squared plus 4x minus 12 divided by the first factor, it would give me the second factor. Or I could have done x squared plus 4x minus 12 divided by the x plus 6, and that would have given me the x minus 2 factor. So think about those families of facts and think about division as you're working through this, because it's going to be necessary for you to be thinking in those kinds of terms, okay? So let's scroll the page up and continue working on some notes. So we're going to be taking these polynomials and we're going to be taking them from their factored form to their standard form. And so to do that, you multiply all the factors together. Because remember, standard form is descending order, greatest exponent goes first, then the next, then the next, then the next. And so we would need to multiply them all out in order to put them into standard form. So that's the first thing that we're going to do. The second thing we're going to do is take them from standard form, where they're already all multiplied out, and we're going to put them in their factored form. So you need to change this typo. We're not going standard form to standard form. That doesn't make any sense. We're going standard form to factored form. And that's where we would do division. So factored form to standard form means multiply them. And standard form to factored form means divide them. Okay? And so let's look at the first example. We have to multiply these all out. So when I'm doing this, I always like to multiply the second two out first and leave this binomial in the front that I will then distribute afterward, instead of having the binomial left at the end. That's sometimes confusing for students. So multiply the second two together, and since they're binomials, we're going to need to FOIL. Okay, first, outside, inside, last. So I'm just going to leave this x plus 1 out in the front, and then I'm going to FOIL. First, x times x is x squared. X times 3 is 3x. 2 times x is 2x, and then 2 times 3 is 6. Combine like terms. So x plus 1, I'm going to have x squared plus 5x plus 6 equals 0. Now what I have to do is distribute that x plus 1 to everything inside the parentheses. So this is way back in Algebra 1 when you learned how to multiply polynomials. I'm going to take this x and we're going to multiply by everything in this set of parentheses. So x times x squared is x to the third. X times 5x is 5x squared. And x times 6 is 6x. Okay? Then I'm going to take the 1 and distribute it. 1 times this, 1 times this, 1 times this. So 1 times x squared is x squared. 1 times 5x is 5x, and 1 times 6 is 6. And then what we do from here is we combine all of our like terms, remembering to put them in descending order. So x to the third, I have no other x to the thirds. 5x squared plus another x squared gives me 6x squareds. I have a 6x and a 5x. Put them together gives me 11x, and then plus 6 equals 0. So factored form, where all my factors are separated, x plus 1, x plus 2, x plus 3, and standard form, where they're all multiplied out. So factored form and standard form. Okay? Second example, right beneath it, same idea. We have to multiply everything out. Okay? So we're going to multiply these out first. And remember, we have to FOIL. So I'm going to have x plus 1 times x squared plus 2x plus x plus 2. I'm going to combine my like terms. X plus 1 times x squared plus 3x plus 2 equals 0. Now I'm going to start my distributing. X times all of those. So x times x squared, x to the third. X times 3x is 3x squared. And then x times 2 is 2x. In blue, I'm going to distribute the 1. So 1 times this, 1 times this, 1 times this. So 1 times x squared is x squared. 1 times 3x is 3x, and 1 times 2 is 2. And now I'm just going to combine my like terms, putting things in descending order. X to the third. I have a 3x squared and another x squared. That gives me 4x squareds. 2x plus 3x gives me 5x plus 2 equals 0. So there is my polynomial in standard form. These are not difficult. They're just that you need to be really careful in not making silly mistakes when you're multiplying. Be careful for your signs, things like that. So factored form to standard form. Okay? Then we have to look at the other side of the page, which is standard form to factored form. So now instead of multiplying, we're dividing. So we're going to look at each term. We're going to decide, what can I divide out of these three terms evenly? So this is greatest common factor. And the answer is going to be 2x is what I can divide out evenly. So place your 2x out into the front. And then explain or put into parentheses what is left. So 2x to the third divided by 2x leaves me with x squared. 10 divided by 2 is 5. You had two x's, you took one away, leaves you with 1. 12 divided by 2 is 6. X divided by x is 1, so it's gone, equals 0. And there are your two factors, okay? And then you need to look at, and this is where we stopped in Chapter 5 when we were doing factoring. We kind of stopped right here, but now what we need to do is look at what can I do with this trinomial to break it down, okay? So factors of 6 are 1 and 6, 2 and 3. And I have to figure out how can I get a positive 5 and also a positive 6 when I go ahead and multiply it out. So if I did positive 6 minus 1, that would not multiply out to give me a positive 6, so I can't use that set. So it has to be x plus 2, x plus 3. So this is factored form. All multiply down to the three factors that I used to multiply out and get 2x to the third plus 10x squared plus 12x. So this was standard form, and this is factored form. Okay, let's try the second example. Divide out a 3x. This one's going to be a little bit more involved because we are left with a trinomial that has a lead coefficient greater than 1. So now I need to look at 2 times 12. So I'm going to take this, I'm going to put this trinomial over here and do my work over here. So 2 times 12 gives me 24. So factors of 24, 1, 24, 2, 12, 3, and 8. Ooh, probably can get negative 5 from 8, negative 8 plus 3. So grouping 2x squared plus 3x minus 8x minus 12. Let's see if we can get this to work. Take out an x, leaves me with 2x plus 3. Divide this by negative 4, and that leaves me with 2x plus 3. And I know I'm doing it right because I'm getting the same two factors in the parentheses, 2x plus 3 and x minus 4. Those are going to go here in place of that trinomial. So all factored down, I have 3x, 2x plus 3, and x minus 4. So factored form. And this was standard form. Okay? So remember, that was a trinomial that had a lead coefficient of 2, and I did all the work over here. And remember, we had to use grouping to solve that. That's, again, back in the factoring chapter. Okay? So this is the first part of what you need to know about polynomials and linear factors. We're going to go ahead and flip the page and talk a little bit about maximum and minimums and factors and zeros and things like that. So we'll be doing that in the next video.